Hi, welcome back to the channel. In our last lesson, we saw how to find the Laplace transform of a constant. Now, but in this lesson, we'll be seeing how to find the Laplace transform of the exponential of minus kx, where k can be any number. K can be equals to 2, 3, k can be 1000. Now, let's get ahead with it. Now, we'll be looking for the Laplace transform of e raised to power minus kx. Remember that in our last lesson, we said the Laplace transform of f of x will be the same thing as the integral from x is equals to 0 to x is equals to infinity of e raised to power minus x f of x dx. Now I could have used this is just time domain. I could have used t. I think I used t in the last lesson. Some textbooks will also use t and some will use x. Just shows we're working in the time domain. So that if if the Laplace transform of f of x is equals to the integral of e raised to power minus xx f of x dx, then the Laplace transform of e raised to power minus kx will be the same thing as the integral of x is equals to 0 to infinity e raised to power minus kx, then e raised to power minus xx with respect to dx. Now, if you look at this closely, you see that we can easily rewrite this from our basic indices. Both have the same base, which is e. I can rewrite this as e raised to power minus kx plus xx. I'll put a bracket here because I have negative. Now dx. Now we are integrating between x is equals to 0 and x is equals to infinity. Now I can simply say let u from our chain rule equals minus k plus x, everything into x. Then I can differentiate the u, the x, to be the same thing as minus k plus s plus x. Now this automatically implies that my dx will be the same thing as du over, let's have the negative sign, k plus s. Now I have taken, now I represented u with minus k plus s into x. I can easily now rewrite my integral to be Laplace transform of e raised to power minus kx is the same thing as the integral of e raised to power u du over minus k plus x. Now it's ranging still between 0 and infinity. So that this is the same thing as 1 over k plus s, this is negative, the integral of e raised to power u du ranging from 0 to infinity. Obviously, I can simply say this is 1 over k plus s now into e raised to power u, because the integral of e raised to power u is e raised to power u. It's going to range between 0 and infinity. Now, so that this is the same thing as, remember we have said u from, when we're dealing with it as a function, u is the same thing as minus k plus s into x. I can easily rewrite this now as 1 over k plus s negative into e raised to power k plus s into x. Now it's ranging from infinity to 0. When this is 1 over k plus s, this is negative, into e now will be raised to power k plus s into infinity minus e again into k plus s into 0. Now, when you look at this, you see that e raised to anything raised to power e raised to power. When you look at this, you see that e raised to power infinity is actually the same thing as 0. And 0 times k plus s becomes 0. And e raised to power 0 is the same thing as 1. So I can easily write this as minus 1 over k plus s into 0 minus 1. So that this is the same thing as minus 1 times 0, obviously that's 0. Then minus 1 times minus 1, that's plus 1. That's 1 over k plus s. Now that's how we find the Laplace transform of e raised to power minus kx. So that if I'm asking for Laplace transform of e raised to power minus 2x, this will obviously be 1 over 2 plus s.